Thogus is an injection molding company. Foundationally, we have 20 injection molding machines from 25 tons up to 720 tons. A limitation in our business is capital equipment. Tooling costs a lot of dollars. It takes a long period of time to build a tool. Stratasys is able to take a CAD file, we can import it into the machine and print a part in hours. Worst case scenario, if it's a large part, complex geometry, days, not weeks and months. We wanted to be able to provide our clients initially functional parts that they can use for testing and product validation. What we found after we brought the machine in is there's a far greater purpose to FDM, and it's in our manufacturing process, on our floor. Fixturing, product design, fixturing, end-of-arm tooling, part extraction, labor reduction, 5S, housekeeping, cleanliness, orderliness of fixtures, of parts, of tools, you name it. In every aspect of our business, FDM touches Thogus. We have automation, we've got robots on our machines. Rather than using steel plate or aluminum frame and building these big, heavy end-of-arm tools they're expensive, they take a long period of time to build, we can take a 3D geometry and print an end-of-arm tool that weighs 70 to 90% less in less than 24 hours. And if the design doesn't work, you can make a tweak to the engine, to the CAD file, reprint it again. But it really takes that direct labor cost off of our floor. And I don't care what industry you're in, this will impact it. 3 years ago, Thogus invested in its first robot for part removal. At the time, we had no engineers in-house, so we had to contract out with a third party to design an end-of-arm tool that would extract a part from the machine, palletize it on a conveyor, and degate the part. It was $10,000 in 8 weeks, and it weighs 20 pounds. Fast forward to earlier this year, we designed our own to the same exact functions and features needed for another robot. We designed it built it in 24 hours for $600. I don't know another technology that can do that. One of our manufacturing cells requires us to do an ultrasonic welding application where we have to bond two parts together. Well, our customers' volumes have continued to grow where we needed to automate the process. We went to a secondary supplier that makes the equipment for us, and they quoted us a turntable system where you drop parts in and it rotates around and welds with safety guarding and timing features. It was about $50,000 to deliver to our floor. Instead, I had a junior in college, as an engineering major, design the same exact functionality for $8,800. And the largest portion of the $8,800 was the turntable. 85% of the remaining design is in FDM. I talked about the example of the plates for end-of-arm tooling. Accidents happen. People make mistakes. We're all, that's the days we live in, right? The plates turned into a safety feature for us. We built a new tool. We were lining it up. We had one of our new young engineers orienting the robot to drop down to extract parts. And when he programmed the robot to drop, the tool wasn't open far enough, so we actually crashed the end-of-arm tool into the mold base, our customer's mold base, and the plate broke. ABS plate broke. So it actually turned out to be accidentally we found a safety feature in this, because if that would have been a steel plate, we would have damaged the robot, the motors, we would have damaged the alignment, we would have damaged the customer's tool, which is more important, and we would have delayed the process of getting the job sampled. We have 5 machines right now. We have 2 dimensions, 2 Fortis 400s, a 900, and a smoothing station. Obviously, we believe in Stratasys' technology. We're heavily invested in it. In the next 5 years, I think Thogus will have, or RP&M will have more Fortis machines than injection molding machines. And as of today, we have 28 injection molding machines. I see Stratasys' technology as the future of manufacturing.